Hey guys, here we are again, Cal 1. We're going to look at number 18 for my homework. Here we go. This question is asking for the area. It's not asking for the net area. It's asking for the real area. So we may need to sketch a graph here for this. Okay, we do have a polynomial function, and we're given a specific interval from -1 to 2. So first thing I want you to see is that there are x-intercepts. Let's do an x-intercept to find some points because we're going to sketch this. So I know that x to the 3 minus 1 is going to equal to 0 when x is 1. So I know that 1 is its x-intercept. So I know that's the point 1, 0. So now I'm going to get a couple of more points. I know 1, 0. I'm going to do -1, 0, and 2. And let's get a little sketch here going on. I'll plug in -1. I'm going to get a -8. Again, stop the video if you need to sit here and calculate this. I've already pre-done them, and just for the sake of saving time on the video, I'm going to go ahead and tell you what they are. If I plug in 0, I'm going to get -4. And of course, 1 is the x-intercept, and I solved for it. And then if I plug in 2, I'm going to get 28. Okay, so I'm going to do a little sketch here of this graph. The better you are at graphing, the quicker you can get something like this done. But -1, 0, 1, and 2. Now 2 is 28, so that's going to be way up there. Way up there. 1 is 0. 0 is -4. -1 is -8. So I have this graph that looks something like this. Okay? And I didn't want to do the whole thing. All right, there we go. And so I need to find the area of this line, or this curve, and the x-axis from this interval. So I'm looking at the sections. I'm looking at this section here and this section here. So I have two sections. Okay. So this bottom section, when I do this, when the area is actually going to be negative, and so I'm going to do the absolute value of it, or just do the opposite of it. And this area is going to be positive. Okay, and so I'm going to find my total area, I'm going to add them together. All right, so I'm going to use my integrals to find the area. So I'm going to do the integral from -1 to 1. Okay, from -1 to 1. From -1 to 1, because that'll give me that area of my function. Now I'm going to go ahead and put the 4 out front just to make my life easier. That'll give me that one. And then the second one, I'm going to do from 1 to 2 of the same function. Got the 4 out front. And so that'll give me my other one. This will give me my left area. This one gives me the right area. This is the area on the left, and this is the area on the right. Okay. All right, so let's do those real quick. All right, so this is going to be 4 times. So now I'm going to add 1 and then divide by 4. So that'll be x over 4 to the 4th minus x. And then I've got to evaluate that from -1 to 1. When I distribute the 4 inside, I'm just going to be left with x to the 4 minus 4x. And again, I'm going to evaluate from -1 to 1. All right, so if I plug in 1, I'm going to get 1 to the 4th minus 4 times 1. My big minus. And I'll do -1 to the 4th minus 4 times -1. This gives me 1 minus 4, which is negative 3. Here's my big minus. And this is going to give me 1 plus 4, which is 5. So I have negative 3 minus 5, which is negative 8. So this area right here is negative 8. Okay, now when we do the final answer, I'm going to take the absolute value of that one. But it makes sense that it's negative because that's what it was supposed to be. And so now we'll move on to the second one. All right, so the one on the right. Again, when I integrate, I'm going to get the same thing. It's just going to be the same exact integration. I don't even know why I'm writing it again, just for writing it again. It's still going to be x to the fourth minus 4x, but this time I'm evaluating from 1 to 2. So I'm going to plug in 2 first. So 2 to the fourth minus 4 times 2. There's my big minus. And then 1 minus 4 times 1. 16 minus 8. So that's 8. And then my big minus is negative 3. Which is going to be 8 plus 3, which is 11. Okay, so this area right here is 11. Now, the answer, of course, would be the opposite of negative 8, with the absolute value of negative 8 plus 11, which is 19. Okay, all right. Number 19 is the same, basic setup. I'm going to set it up for you real fast, but it's harder because it's a more complicated problem. And our interval this time where is from negative 1 to 9. And then we'll do x-intercepts. We will find that there are 2 x-intercepts. When x squared equals 0, x equals 0, and x minus 8 equals 0, x equals 8. So 2 x-intercepts. One at 8, and I have one at 0. So now when I sketch this graph, okay, where you came from, when I sketch this graph, I'm going to go ahead and give it to you. Our interval that we're looking at is from negative 1 to 9. Okay? And when I sketch this graph, this is just, you can do it on a graphing calculator. It's going to go up and hit that one, come down, come back up and hit that one, and then keep going straight on. So that's what my graph's going to look like. And so then when I do my, where's everything going? Hold on. There you go. And so now when I do my area, I have 3 sections to do. Well, I guess technically I could do it in 2 sections, couldn't I? I could do it in 2 sections. And then the second section. This one here. I could do it in 3 or I could do it in 2. I want you to be ready to be able to do it in 3 or 2. Okay? So now I can do the interval from negative 1 to 0 of my function, which I'm going to multiply out. And then I could do the one from 0 to 8. And then I could do the third one from 8 to 9. Now I said I was going to multiply them out. I'm going to do x to the third minus 8x squared. So again, you could do these 2 together because they're both negative, and then do the third one and get added. So good luck with that one. I'm going to stop the video now, let you finish that one. I may come back and finish this problem on the next video.